Hello, everyone. Good morning, good afternoon, and good evening from whichever part of the world you're connecting from. My name is Manish Shanbhag. I'm from EIPM, and I'll be taking you through today's webinar. Okay. The topic for today that we'll be discussing is value stream mapping, or also called VSM. All right. I can see a lot of you connecting again from different parts of the world. I was just looking at the registrations and I see a lot of people from Europe, largely France, Germany, Poland, Russia, and Italy, and so on. And there's some from the Middle East as well. So, welcome. Good afternoon. And then we have people from different backgrounds as well, right? People from different backgrounds, from manufacturing, a lot of automotive people as well, consulting as well, and so on. So, welcome one and all again. Um, I hope you're able to hear me. And if you have any notes or any questions or comments to make, you can put in your comments in the chat section. I have Eric also, who is in the background, who is helping me in moderating this. So Eric will be also present in case you have any technical issues. He will be there in the background to solve. Thank you very much, Eric, for your support. Okay, right. And I can see some familiar names as well. Hello, everyone. Hi there. I can see some familiar names as well. Yuri, hello. Victor, yeah, uh, quite a few. Okay, very good. Excellent. Thank you very much for joining. The idea is that we're going to have this. Hello from Israel. Hi there. Hi, Jill. Hi. Um, we're going to do this for around 45 minutes, and then we can have some Q&A at the end. Okay. The value stream mapping idea here is put in through the lens of procurement, right? So I know a large part is still with manufacturing and supply chain, but we are trying to put in this through the lens of procurement. So we're going to see what are these details, but we're going to define value stream mapping, and then we'll look at the agenda as well. Okay. All right. Here we go. I'm going to move. Yeah. So you can see typically everyone recognizes this kind of a situation, right? When you put the earphones in your pocket, they come out automatically with knots formed, right? What does that represent? This picture is just a representation of a problem. Okay, what does that represent? It represents inefficiency. It represents waste, lot of loss of time, and loss of value. Okay, and in fact, there is a scientific theory called the knot theory, actually, where scientists have tried to define how are these knots formed automatically. So sometimes you could have processes, you could have systems in place where they are functioning very well, but there could be knots that can be formed over a period of time automatically, right? And we need to identify those. So this is an indication, it's an analogy of a problem. All right, it's an analogy, and we are going to dig deeper and understand why it is connected to VSM. And because that's the essence, that's the skeleton of VSM that we are talking about. Okay, so in the agenda, we're going to look at what is value stream mapping, also called VSM, as we said. What are the key components of a value stream? Designing a value stream, there are certain checklists, guidelines, procedures, so to say, that we're going to look at. And then the application in procurement. So as this is a procurement forum largely, we are going to look at applications in procurement. It's not necessary that it is only in procurement. It's just an application, but the value stream can be used in multiple areas. And we're going to see that as well. Okay. So let's start off with a very classical definition of what is value stream mapping. Okay. So uh, there are some key elements here described on value stream mapping. So VSM is basically, it's a technique, or sometimes people refer to it as a tool as well. So technique or a tool which is used to define and optimize, okay, the various steps, processes, the various steps in the process involved in delivering a product or a service. Okay, so there is a product or a service and we have to deliver it to our customers, right? And the idea here is to define that process and eventually optimize these various steps that are involved in that process. Okay, this is a simple definition of value stream mapping. The three keywords that come out of this definition is illustrate. So we have to understand what is the process, right? Illustrate the process, analyze it, identify these knots, right? Identify the inefficiencies, identify the wastes, and then optimize and improve. Okay, optimize and improve. That's the key three words that come out of a value stream mapping. In the process, value stream mapping also is a visual aid to look at all the steps in a process. Okay, it's a visual aid. So when you're drawing, actually, a lot of value stream mappings are hand drawn. Hand drawn. So it's a visual aid to look at all the steps in a process. Uh, then it's a support tool for lean implementation. It's a start point. It's a tool. So some of you, especially people from automotive manufacturing, you have the lean, you have Six Sigma processes, you have all the total quality management process, and so on and so forth. Value stream mapping can act as a support tool for implementation of lean, for example. So you have that as a base, and based on that, you can implement lean, because the notion is fairly similar. We are trying to cut waste here, the muda, what we call, right, in Japanese. So we are trying to cut waste. Okay, it highlights the inefficiencies, the waste, the knots from the wires that we saw before, and it also forms the basis of an improvement plan. So based on the value stream map, based on the illustrations that we have done, based on what analysis that we have done, the improvement action plans are based on that. Okay, that's the overview. The primary objectives of a VSM is to remove the waste, as we said, waste or knots or inefficiencies. That's one of the primary objectives. And of course, the other objective, always keeping in mind the customer need. Okay, keeping in mind the customer need, and at the same time, how to optimize it and improve it and remove waste. It's largely, I mean, the notion of VSM started largely in the manufacturing and supply chain, right? But now it has moved beyond it to logistics, even software development. You have product development that uses VSM, and so on and so forth, right? And this is precisely what we are trying to do. We are now trying to see an application in procurement. Okay, we need not use the absolute full, let's say, full gamut of all the choices that we have in VSM that we use in supply chain, but it's a good starting point to at least look at the processes, to illustrate the processes, to analyze these processes and improve them in any other area. So this is where we're going to look at procurement as an example. Okay, so that's about value stream. Remember these three keywords: illustrate a process, analyze the process, and improve the process eventually. There uh, is an example. Okay, there's an example of how a very classical value stream map would look like. Okay, so very simple. So you have the supplier and the customer on one side, and then the company operations in the middle. Okay, so let's say there is some input. Some of you might be already familiar with the SIPOC process, right? The SIPOC process, the supplier, inputs, process, output, customer, right? So this is again quite similar to that. So we have the supplier on one end. I'm going to show you a real picture also in a bit. There's a supplier on one end. Then you have the inputs. You have the inputs, these inputs here, and you have the process steps that is within the company operations, and then you have the output that is delivered to the customer, right? And in the process, you have from step 1 to step 2 to step 3 to step 4 and step 5, whatever is the product or service that is being delivered to your customer. In that, we have a lot of data, a lot of information, and a lot of physical flow of material, right? A lot of physical flow. We will look at later on some of the limitations of value stream mapping, where there is no physical flow or where there could be no information flow. VSM may not be the best tool to use, but we'll see those limitations later on. But largely here we are talking about something that comes in. So all our inputs, the way we are processing those inputs, and the output that results, and what we are delivering to the customer. So we're trying to analyze each of these steps, illustrate those steps in the as is form, then look at the possible analysis, where all you can analyze it, and then improve plans. Okay, There's data, then there are a lot of other parameters that we can include. The classical one includes typically the wait time or the lead time overall, and then the process time of each process step. Okay, so the idea is to try and optimize that process time, to try and reduce the wait time. There could be a lot of data that that needs to be probably cleaned up. There might be shortening the process step itself. There could be optimization of the process step, and a lot of other factors that can be used. Okay, to improve the eventual flow from your suppliers to your customers. Okay, this is a very classical definition of a value stream map. So we have this is an example. I just picked up an example to show you a picture how it can be done. So you have your suppliers, you have all the company operations here, all the details. When the supplier delivers, we have all these processes that happen. You have maybe a few hundred suppliers delivering, and then we have all the inputs coming here. We have, irrespective of whether we're making a product, delivering a service, or even just to analyze a process, all this can be analyzed over its lead time, over its process time, cycles, and so on and so forth, and then delivering to the customers. Now, in a classical supply chain setting, we would also involve a lot of, probably some of you already are aware of this, of the cycle time or the takt time. We are trying to improve all these kind of processes, but in this case where we're talking about procurement, we're not going to go into the technical details. I'm just going to define the process to do it and the application and procurement. We're not going to go into the technical aspect of how to calculate cycle time or how to calculate takt time, or how to improve the process time and so on and so forth. Okay, so we're not going to get into those technical details, but it is to give you an idea of a real case where you see the maps can be drawn like this. Okay, this might look a bit complex, but we'll try and simplify it now going forward. Okay, the other thing that we need to also be very clear when we talk about value stream mapping is a difference between what we call value stream mapping and what we call process mapping. Okay, so I've just tried to jot down because I get a lot of questions like this. What's the difference, Manish, between value stream mapping and process mapping? So I've tried to make a comparison between VSM and process mapping. They're not super different. They're not super different. They are falling within the same bracket of illustrating, analyzing, and improving. So both are having the same crux of elimination of waste, but at different levels. So the primary purpose is, yes, there's waste elimination, but here we are talking about a bit more strategic. VSM, we're talking about a bit more strategic. We are looking at evaluating functions, right, in a business. And in process mapping, we are looking at the tasks within that function. So it's a bit one level deeper. Yeah, it's at a micro level. So the level of detail in process mapping is micro, whereas VSM, it's macro. We are looking at a bit more strategic level, whereas in process mapping, we are looking a bit at a micro level. In terms of functions, VSM can be cross-functional. There could be multiple VSMs crossing each other. If procurement does this, or if finance does this, or if production does this, R&D does this, there's a lot of overlapping that can happen. Whereas in process mapping, we just focus on one particular function and then we evaluate the tasks within those functions. So it's like a subset and a superset kind of notion. Okay, the time frame also is different. Typically, process mapping is done quicker. VSM might take slightly longer. The teams are different. As you can see, some of the differences that you have here. The focus, as we said before, elimination of waste, as well as very customer driven. We're looking at the customer need, where here we are looking at more of improving internal efficiency as well. In the process, we will do that in VSM as well, but it's more at a strategic or macro level. Okay, so these are some differences that I wanted to highlight because I get that question a lot. So it's just to get you an idea. Okay, so having defined VSM, the key takeaways is illustrating the steps, analyzing them, and improve them. Okay, that's the key takeaway of this part for you. We're going to look at what are the key components. Okay, the key components of a value stream mapping, and within that, we are not going to look at some of the technical aspects, but one of the key main aspect, the key things, the key components, the three key components that we are going to analyze are the following. One is the value added. Okay, what are all the value added elements? So this is the actual conversion from inputs to outputs, right? And this is what the customer is paying for. The customer pays for this value add. The customer doesn't pay for non-value add. Okay, these are the actions. These are the non-value added actions are the ones that should be eliminated. This is the waste. The customer doesn't pay you for waste, right? So this is where we're trying to eliminate it. And then there's another level, there's another category, which is the essential non-value added. Sometimes you might refer to it as also necessary non-value added. Okay, so there's the essential non-value added. These are typically actions that are wasteful, yes, but they are necessary under the current operating procedures. Okay, for example, there could be government regulations. Okay, there could be government regulations that you need to follow, right? Now, this is a standard. The customer is not paying specifically for you for this, for that, but it is necessary. It is a part of the current, or you have restrictions to use certain old equipment, right? The customer is not paying for that, but it is essential for your business to run. It is non-value added. It's old equipment, remember. So it may contribute to non-value added, but it's essential under the current operating conditions. So these are the kind of tasks where we need to identify, and the objective is, as we say, when we illustrate this and we try and analyze this, when we come up with these three different areas, when we talk about improvement, the objective is very clear. We want to increase the value add, right? We need to understand what the customer is paying for, understand the needs, and increase the value add. At the same time, eliminate the non-value added and see how to optimize the essential non-value added, sorry, how to optimize it and eliminate the waste or the non-value added tasks. Okay, so there are the three things. There are some other examples here. Wait time, as no, the customer is not paying for wait time. The customer is not paying for excess resources or idle resources, overproduction, and some of the compliance parameters. So all these elements are non-value added, where the customer is not paying for it. Okay, so we focus on looking at the value added, eliminating the non-value added, and optimizing the essential non-value added. Okay, this is the essence. They are the key components within a value stream map. All right. This is a very classical one. I've picked it up from Lean. So because, as I said, there is the value stream mapping is a tool or a technique or as a standard to then implement Lean as well. So I use the same notions of wastes, and probably some of you who are familiar with Lean are already familiar with the 8 wastes, the mudas that we talked about. These are the defects, right? Defects caused by whatever, by rework, scrap. The efforts caused by rework, scrap, and so on. Overproduction, production that is more than needed, or which is before it is needed. Waiting times. So we know about waiting time. So this is wasted waiting time for the next step, as the customer is not paying, right? Sometimes it is non-utilized talent. So we're not touching purely on some of the product aspects, but purely on people aspect as well. Skills, resources, the knowledge of these resources. So this is non-utilized talent. Transportation, unnecessary movements of products and material. Yeah. Inventory. So excess inventory would be waste. So in these days, it is a bit challenging because during the COVID times and just after the COVID times, there was a phase where, due to the supply chain disruptions that we had, a lot of companies decided to put in an additional buffer inventory, right, whenever it was possible. And now they've realized, oh, you know what, we probably don't need, as the supply chain problems begin to ease, some of the availability of raw materials begins to ease, then we see that, this can become a waste. We have motion, unnecessary movement of people, unnecessary movement of material again. And then you have extra processing. The customer is asking for something and we are working in a higher quality than is required by the customer. So even the extra processing can be considered as a waste. Okay, so these are all these tasks that we are talking about where we say these are non-value added tasks. The customer doesn't pay for any of these tasks. The customer is paying for value added largely. There could be rare exceptions, of course, due to the conditions, but largely the customer doesn't pay for non-value added, and these are all these non-value added wastes that we are talking about. Okay, so identifying this becomes very critical in that process. All right. So having said that, we are going to now look at a bit more detail on how to design. So it's a step-by-step guideline basically on how to design a value stream. So we understand what is a value stream mapping. What are the three key components? Yeah, I just focused on there are other elements, but these are the primary ones. Okay. And then we look at how do we design a value stream map. So this is just a guideline, as we said. And the guideline is the following. I've just tried to come up with two different varieties, but they are basically the same, right? Here we are talking about first step. They are stepwise, as we said. The first step is selecting whatever you want to work on. So it could be a product, it could be a service, it could be a process. Okay. In product development or in service optimization or in process. So we want to first select the area in which we want to work. A team is very important, so as supply chain, as procurement, we are not it's difficult to do this in silo. Okay, it's difficult to do this alone because there could be a lot of other parameters, it could be a lot of other inputs that you might have to get from other departments, and it also acts as a good icebreaker if you're not talking with certain departments, right? So that's already a good thing. So we're talking about setting up a team, a strong team with a sponsor or a leader, uh, who's going to be the accountable for this. Then we draw the current state map. Okay, whatever is the current state of the process, whatever is the current state of the product manufacturing, whatever is the current state of the service delivery, we draw it as is. Okay, we're not trying to optimize it now. We're trying to draw it as is, whatever is the current state. Okay, the next step within that current state is to identify the value add, identify the non-value add, as we have seen, and identify the essential non-value added activities. Okay. Then we draw the future state map. How would I want it to be? In fact, there could be medium steps as well. So the future state could be done in splits. So in the next 1 year, I want here, but in the following year, I want it here, and so on. So if the big jumps are not possible, we draw a future state map. Okay, so we have a current state, identifying the issues, future state map. Okay, and then we are looking at elimination of waste and areas of improvement to meet the future, to go to the future state, and in the process to meet the customer needs in a better way. Okay, once we look for these areas, we develop the action plan in detail to implement. Right, in detail to implement. Now this might already also like, oh, this is common sense, I just need to know what it is now, what it is going to be in the future, eliminate. But that is exactly what it is. We are trying to identify and dig deeper into these value add, non-value add, and essential value add, non-value added areas, and then try and solve them, try and optimize them. Okay, so this is the overall guideline in how would you go about it, right? How would you go about looking at the step by step? How would you go about it? There's another similar one that I've put in. It's exactly the same. The one thing which is critical here, which I not mentioned earlier, is you have again the team and the process that you select. But what is recommended is actually go the Gemba, actually go on the shop floor, or actually go where you want to highlight where the problem is coming from, or where you want to analyze it, and collect the data yourself. A lot of the times there could be issues where you're just asking for data and then the data might not be accurate. So the Gemba part can be very critical in certain processes. Okay, the Gemba part can be very critical. So you go on the shop floor, you go where the action is happening, and you collect the data. Okay, once you do that, you establish the as is state, as we said, identify this, design future state to be, action plan. There's another area where it says design to be future state, or the ideal state. How would you like it to be ideally? You could eventually reach there, but depending on the available resources to work on it, etc., ideal can be a bit far-fetched sometimes. So rather, we look at what are the realistic future state that we can achieve. Okay, and then come up with the action plan. So this is the step-by-step approach to VSM. Okay, and in the process, when we are identifying value added, non-value added, and essential non-value added, I've put in a twist now. As I said, this is largely not very classical supply chain or manufacturing related. I'm trying to put in the element of value, which is defined for procurement. Okay, so as we know, and this can be anywhere else as well, yeah. So when we are talking about value, some of you who have interacted me before also probably would have seen this. When we define value, we are talking about the customer benefits or satisfaction as a function of costs, right? So when we are trying to improve the value and we are looking at removal of waste, we are essentially decreasing the denominator here. When we remove waste, we are trying to reduce our costs, which thus increases value. And on the other side, work well with customers, see if we are over processing, see if we are over producing, the defects that we generate, etc., etc. All this would not satisfy the customer, right? So we are focusing here on customer needs to increase the value here, increase the numerator or decrease the denominator in order to create more value for the customer, right? So this is where we identify those tasks which are value added, non-value added, and essential non-value added, and then work on these individually, which are the ones that will contribute to these values. And then of course you can do further beyond that. You could select the actionable ones or the priority ones and so on and so forth. So that's another addition that you could also do. Okay. Now, having said that, just one point on some of the questions that you can ask when you're designing the current and the future state. Okay, so the questions while designing the current state. This is non-exhaustive. Just put down some elements of it. What is the current state? Of course, why was it designed this way? There could have been some reasons that it was designed this way whenever it was designed, right? But given the fact that we have had the environment changes, market changes, internal process changes, organization changes. There are so many things that are happening in companies on a continuous basis that at a particular time, whenever the system was designed, it would have made perfect sense. But now it doesn't make as much sense as it used to do before. Right? So why was it designed that way is something that we need to understand some of the root cause. Who designed it? What would be the reasoning behind designing it this way? When was the current state designed? It could be before a big event, like let's say we have COVID, for example. It's a significant event for many of the operations of the companies. Maybe something was designed before, and now probably there are some changes necessary. Where was it relevant? How did things work, and so on and so forth. Okay. And some of the questions while asking while you're thinking about a future state, what does the customer really need? You need to understand, have the needs changed? A lot of the times the needs are changing, right? And if you have the same old process following a new need, we might be automatically introducing those knots or those inefficiencies, right? How often will we check our performance? Which steps create value? Which are waste? We solve these. How do we control work between interruptions? Appropriate balance workload, etc., etc. Okay, so there are some of the questions that we would try and ask before we are designing the future state. Okay, so this is current state and then this is future state. So now, having said that, now we are going to look at one application, very simple application in procurement. I'm trying, as I said, I'm focusing on procurement. There are plenty of applications in supply chain that we are doing this, but VSM has not been used much in procurement. There are other tools for sure. We're trying to see how we could do this in procurement. Okay, so one example here, that there could be various examples of value streams in procurement. Again, I've just listed down 3 or 4 here. Let's say you have purchase request to purchase order. Okay, the process of converting that. This is more operational procurement or purchasing in some companies. The procure to pay. So another very operational part. The other one here could be slightly different, where the costing manager is studying an RFP, let's say, and is proposing a solution to the customer. Right, so this could be one where you're already working at even the bid phase. Procurement working upstream on category strategies. This is very classical, right? More strategic. where there could be certain procedures, there could be certain inputs that you might require, and there could be a process to follow that, right? So there could be multiple areas, and we need to all start to build up such kind of a VSM process in procurement to make sure that we understand the as is well and what is the situation in the future and the elimination of some of the waste activities. Okay, so the example I'm just going to take is a simpler one here for the purpose of this call, is the purchase request to purchase order. Very classical, very classical. Everyone would have probably seen this. So we'll try and map it on to a very simple VSM process. So here the first thing that I'm going to do is we're going to follow this procedure that I just highlighted right before. So this is the procedure that we said. Select product process service. So we have selected that purchase request to purchase order. You could have a team, a sponsor, a leader, whoever is going to look behind. Draw the current state map. We're going to look at these, identify VA, NVA, and ENVA, and draw the future state map, design the lean flow, and then looking at the action plans. Okay, so we're going to do this for the example that we have chosen just now. Okay, it's a simple illustration of the application. So the first thing is, this is an example. So this is, I've done it, there could be variations, but I'm trying to keep it as simple as possible. This is the purchasing process. So you have the internal customer, right? Here we are talking about an internal customer, right? Where we are serving the internal customer. And the internal customer raises a PR, and then eventually we are sending a PO to the supplier. That's the input and the output, okay, effectively. And then you have all the process in between. Okay, so let's say the information comes in, we have to create a PO, we send to the supplier. This is the supplier here outside. It goes outside, there's a review, there's changes, maybe there's exchange, and the supplier accepts. But then there could be other reviews that can be put in place for internal procedures. So this is some internal teams, maybe finance, maybe legal, who has to validate a few things. And then eventually, once all that is validated, the final PO comes back to procurement, and then procurement sends it to the supplier. Okay, there could be iterations through this. There could be exchanges, which is the reality in life. Sometimes when we are sending a purchase order to a supplier, there could be iterations, and there would be some exchanges before final conditions are agreed upon. Okay, I'm just talking about PO. I'm not talking about, we're not venturing into contracts or frame agreements or something like that. Just a simple PO, which is a type of contract, but we are just looking at a simple case. Okay, so here we are trying to identify the process steps. We are trying to look at how much time it takes, right? Remember, the focus is also looking at eliminating waste and improving efficiency. So how much time does it take to do this? What is the wait time here? What is the processing time that you can mention here? So half an hour, maybe. Then it goes to the outside the company where you're not in the processing time. This is not applicable. This is only the supplier. This is going outside. Then it comes back internally, and internally you might have another couple of other procedures to finalize it, and so on and so forth. And then the final PO sent to the supplier. These are all the process time. So 0.5 plus 0.5 plus 1, and probably you have 2.25 process time. There's a wait time. Every time you can calculate the wait time. As an example, I just wrote maybe you have 3.5 hours wait time here, and your wait time here, and so on. Okay, so you add up those wait times, and we are looking at only internal processes, right? Once it goes to the supplier, let's say the lead time here at 48 hours, you give some deadline to the supplier, but it's not a part of your process time. Okay, so this is just to give you an example of how this can be done. So different companies would have different procedures here, so you can map on your own. This is a classical one that I picked up. Okay, once we do that, we identify, as we said, what some of the value added. So value added may be the initial review with the supplier. There could be some internal checks which are value added, and so on. The non-value added could be defects in the PR, right? The information that comes in itself, and this happens a lot. And then there is some complaint saying, oh, the business doesn't give us good information. So we need to identify. There could be errors. This is a non-value added. Your end customer is not paying for this, right? So this is non-value added, which increases. Here we are talking about internal procurement as a department itself. So your supplier and customers are different, but eventually we are still talking about input and output, right? So if the defects are errors in the PR itself, that's a problem, because it might increase some of the process timing, and so on and so forth. If there are some areas, these are all the wastes that we talked about, defects or production and so on. If there are some transportation inventory which may not be even applicable, we're not talking about inventory, it's not applicable, so you can also mention not applicable. There could be waiting time, waiting from internal teams. There could be extra processing, right? Maybe you have much more complex terms and conditions within the PO that are not really necessary. Yeah, this is extra processing, they're not really necessary. And then we identify some of the essential non-value added to optimize. Maybe there are threshold levels of workflow. There could be compliance, company compliance, that you have to follow XYZ procedures. Again, this is non-value added in the process itself, but again, these are essential because you have to follow certain compliance in the company. Okay, so once we have done this, we identify what are the key areas, and then we identify where are the focus areas that you want to put in. Maybe eliminate this one, eliminate waiting time. What are the areas that we want to improve on? So again, some suggestions that I have done here, very simple. So maybe in order to reduce defects, probably there could be certain templates. Some of you might be already doing it. I've seen some companies implementing this as well. There could be some areas where you ask the internal customer to have this kind of templates which acts as an input. When I was working in one of my previous companies, we had put in this system called the firewall. Okay, and it was largely a procurement initiative to make sure that we get streamlined purchase requests. Okay, because otherwise the user was going left, right, center, everywhere, and we are going to get this streamlined inputs through a firewall. So we had a system called firewall. It was a digital solution at that time, with certain inputs, templates, and so on and so forth, where the ease in which we got the request became, it was much easier. There was much less interaction than optimized interaction between procurement and the business to get that. So there could be you could have something like that. Then there could be some digital solutions, in this process, to reduce the lead time here when we are going out to the supplier. Maybe this is not adding to the process time, but there could be a digital solution here. There could be digital solutions making the workflow easy, digital signatures, etc., that some of you might be already doing it. There would be some easier way to cross check information and so on and so forth, because remember, we are talking about one PR to one PO. Multiply that by a few thousand, multiply that by a few hundred. This can reduce a lot of work, right? So this is just an idea again. So effectively, I'm trying to see then how can I reduce that process time, which was 2.25 hours before. I reduce it here, I reduce it here, I reduce it here with these different solutions. I am eliminating some of the non-value added. I'm identifying, oh, this is absolutely necessary, so I need to keep this. And then I'm trying to optimize the essential non-value added through these different solutions. Okay, so that's the idea. And then we look at the action plans. So who does the template? What are the details, or template or firewall example that I gave you? Yeah. What about the digital workflow? I'm working with IT and et cetera, to improve this and so on. So the key point is here, remember the questions that we talked about. The questions when this was originally designed might have been absolutely perfect at that time. But given the new solutions available in the market, given the environment changes that happen, more and more suppliers also embarking on digital transformation, it might be easier solutions to get these, and then make sure that you eliminate some of the waste which was established. A lot of the times we work with legacy procedures, which at that time made perfect sense, but today, given the environment, might not be the best best solutions. Okay, so this is how the flow might happen. And then we identify these, we eliminate, and then work on the action plan in detail. Work on the action plan in detail, who does what, and so on. A couple of elements that internally, based on your strategies, you might have to decide is a trade-off that you want to do. Okay, so this is just a trade-off map. In any operations, you have, if you want to give a good quality of service with a high cost, then you accommodate all that variability. Okay, so if you have good quality service, that you want to provide, and you have a high cost of service, you are accommodating all variability. There could be plenty of variations in this particular case. There could be hundreds of variations that are coming in as a part of the purchase request. If you're absorbing that, accommodating that, you're giving great quality, but also the cost of service will be high. If you put in templates, if you put in certain procedures, the firewall, then yes, this is where you will have the cost to serve is lower. At the same time, you will have a great quality of service. Okay. What you want to avoid is possibly a high cost of service and a low cost of. This is where the waste elements can come out very quickly. So it's a trade-off where you want to be. You can still be here, but decide that I want to be here. I want to accommodate as much variability. The batch size one that we call. Each customer is different. Each input is different, and I want to customize and variable and adapt to each of these variabilities. So either you do that. It's like the supply chain as well. Agile supply chain versus efficient supply chain, right? So in an agile one, we are trying to adapt to the variability. In an efficient one, we cut off certain variability in order to be cost effective, right? So these are the kind of decisions that you need to take, where these action plans you want to put in. Okay, so that's and on top, then choose the priority action plans that you want to work with. All right. Then some of the tips. So we're looking at this flow. This is what we saw. This flow. Do the as is mapping. Identify the value added, non-value added, and the essential value added. Then look at the real areas in which that you can highlight it. This is where I want to go in the future. These are my customer needs. All those questions that you need to identify, and then put in place specific action plans in those areas, which are realistic, which are again within a certain time frame, and then work on these details. Okay, so some tips on VSM here. Of course, you'd have this is very much applicable in a product service process, a distribution channel, or even a business segmentation. There has to be physical and information flow. I've not seen a VSM which will work well where there is no information flow or there's no physical flow. So majority of the processes, majority of the products, services would have this. But if not, then VSM may not be, because we're talking about process time, we're talking about wait time, we're talking about one system linked to the other, and so on and so forth. There has to be certain flows, right? In some cases, this is just a tip, but some cases people would want to work with the end and work upstream to the start. It's like reverse, right? They would want like a reverse engineering process. You would look at the end and then work upstream towards the start. That's also one way to do it. Of course, focus on data quality and accuracy. As I said, Gemba, collecting the data quality is very, very critical here. Okay. And finally, there are some limits. It's not all great. There are some limits. VSM doesn't directly address lean manufacturing methods such as Six Sigma, or where we're trying to remove variations, or 5S, or any other kind of systems like this. It requires teamwork, as I said, for problem solving. There are multiple areas in which you might need to connect to multiple people, get inputs from different departments. It's not a catch-all multi-purpose tool that solve all problems, but it's a good tool that will solve problems at elimination of waste and focusing on the customer need. If there is no material or information flow, as I mentioned, a VSM may not be the best tool, right? And the symbology. So I have this in the appendix. So this is a very classical one that I pulled out. This is a very classical some of the tools, but this is very much supply chain focused, so I didn't want to go there, right? But you could have some symbols like this that you could use. You can pick that up from any system. So it requires proper usage, it says, but that's fine. I mean, as long as internally you understood the key areas. The symbology talks universally with multiple people, but you could also define very simple procedures to follow through in the process itself. Okay, so these are the key limits, let's say, of VSM. It's not a catch-all multi-purpose tool, but it's a very strong tool. It's a good tool when you have material information flow and you're looking at improving certain processes or product development or service deliveries to your customers. Okay, right. So this is what we have seen. What is value stream mapping? The three keywords, remember: illustrate, analyze, improve. Okay, key components, value added, non-value added, essential non-value added, trying to identify after we do the as-is mapping, and then looking at uh, eliminating those, eliminating the non-value added, optimizing the essential value added, and then increasing the value added. And then we look at designing a value stream through that procedure, selecting a team, selecting a process or product or service, then looking at the as is, then looking at identifying those three key components, and then looking at the future state, eliminating the waste effectively, and then look at one application, simple in procurement, on the application of this. Okay. Right. So that's what we looked at. A very basic, very quick overview for those who might be already doing this. It's great. You could also share your comments or inputs through this. But then, if some people want to start off this, the idea of value stream mapping is great, uh, but it has to be applicable on the right area, and it can give you really good results. The key point, another one as a concluding point, I would say, is we have had a lot of changes over the last 1, 2, 3 years in the business scenarios, in the markets, in organization structures, and so on and so forth. So I think it's a good moment to go back and understand our value stream mapping. Do this in certain pockets of your business areas that you're working with, and you will probably see a lot of inefficiencies and waste that you can remove. Okay. All right. That's it from my side. Okay, that's it from my side. Any questions, queries? I'm going to look at the chat section in a bit. Eric, uh, you're there, hopefully, with me. Thank you, Jill. Thank you for the emoticon. I can see that. All right. Any questions, queries, or comments, even if you want to provide, or if you want to share your experience through chat, uh, please feel free. We'll leave the forum open for a few minutes for that. Yuri, thank you very much for your comment. I hope you're doing well. I can't hear you, but I hope you're doing well. All right. Cedric, thank you very much. Okay, anything? Danielle, thank you. Senthil, thank you as well. Yes, it is basics. Yeah, I agree. Yeah, it is. But that's the idea. That was the idea. It's to introduce. So you might be already well advanced to this, but it was largely a generic. So, what do you think about applying VSM in the supply chain to your supply? Actually, this is where VSM originated. Actually, in the supply chain operations. Okay. Now, if you look at tier suppliers management, you could do that as well. Of course, it depends on how your procedures are defined, how you are looking at your tier one, tier two, tier three, and go beyond till what level you can go. Because the challenge there is understanding data. Till your tier one, you have good visibility. But if you want to go beyond tier one to your tier two suppliers, sometimes data availability can be a big challenge. So mapping on processes can be difficult. But if you can do that, absolutely applicable. Yeah, I think it was asked by Igor. Yes, so absolutely applicable as long as you have a good visibility and data. If you're not working with the right quality of data, you might waste a lot of time. Yeah, you might waste a lot. That's the reason why we said mapping that procedure. If you have good visibility, you could do that. Okay. All right. Any other questions? Eric, I guess you're getting the information. I'm just looking at the chat. Okay. Good. I will leave it open for a couple of minutes if there are no more questions. Again, I thank you very much for your time and hope to see you sometime again. All right. Thank you very much. Take care. Okay. So, Eric, if there are no more questions, you could close this. Thank you, Alex, Magdalena. Hello. You can close this whenever you want. Yeah, Eric. Thank you very much.